Chapter 7 Pre-Processing. Pre-Processing, Lecture 1. Let's look at this GNU tool. And every tool have different compilation flow. Okay, every compiler has its own compilation flow. Let's look at this GNU tool environment on the left. So basically, you have your C language .h.cpp.h. So if a module including toolpath.h and .geo.cpp. So far, you know that, right? And then actually, this file .h file .cpp file need to go through a stage called pre-processing. And then something called macro and include file will be expanded back to C format and then compile with C or C++. So GCC for C compiler, G++ for C++ compiler, okay? And then you will generate, either you dump to assembly code or you dump to machine code, object code, and then each module has its own .o code. And then eventually you link them together to a .exe file. But in Windows, it is called exe file. In Unix, there is no extension. Unix file can be a.exe, that's fine. It can be it can be a.o, it can be a.objct, something like that. Unix is very, or Linux, the file name is very flexible. Is that okay so far?
Yeah.
And so far, I have not teach you this GDB GNU project debugger yet. It's too early. But make sure that later when you develop the C++ program, using more the black window one, the window plus R key, and then putting out the window, use more of that, because on Unix, you will be using this GDB heavily. Okay, your school would be using this GDB heavily. That's something you need to pick up. And on the right-hand side is Visual Studio. It's probably your ICS51 will be working on this, the Visual Studio, and it has its own GDB, this same function for this. So that's a debugging environment, and it can call this GCC, as you see. You can call the Visual Studio is a tool, it's an editor, but you can call it GCC, and you can also call the Microsoft Visual C++. Okay, it allows you the option to pick different compiler. Okay, and then so it has the GDB and it has a linker, and then you can include file or something, and then you can debug on your hardware. So that's why this one GCC plus linker, this one may work on Visual Studio. So that's assume that your 51 will pick this path, and I'll try to help you to set up the environment. Is that okay? And at this moment, focus on whatever we have, using Notepad++, or using Dev with C++, that's fine, okay? Because this data or whatever file still can pull into this Visual Studio, and Visual Studio is a more complicated tool. But that's the tool we will be using later in August and maybe early September. Okay, so overview: the C language and C++ languages had a preprocessor, often called as CPP, C preprocessor. Okay, but it's because of the .cpp already used for C++, and so this not a lot of people still call this. It's a macro processor that is used automatically by C compiler to transform your program before compilation. What does this mean? This means like, as I showed you last time, you have the include, right? And then you have something like a.h, or you have the include, right? And using angle and then a.h. So when you use angle, where will you get the library file? Remember that?
Preprocessor?
No, when you use angle, where will you get the .h file?
From the library?
Yeah, into the library that you set up in what? In as I show you the what? That's a min.gw. Min.gw. This one minimum GCC window version 64 something there, and then there's a library, right?
Yeah.
From there. But this .h it will be from your own local directory. So when you say if your .h file is too many, you can put a system /a.h. That will be your local directory slash system, and then under layer it's a process .h. And you can also say for image processing tool, you can do image and something .v.h, something like that. Is that okay?
Mm-hmm.
So this one slash means like in your local directory there is another directory you need to go into. Same thing for if you are in a system from the library, you can also have that slash things. You can go down one directory level to get a file. And the preprocessor will be expanding your code. So when you have a C program, so here is your C program, and you have an include, right? So whatever, and you have many include. So what it will do is actually this one will be getting those code and expand it to like f function, something like that, and put into here before you do compilation. So basically it's expanding a lot of code from the library and then directly porting into your program and then start to do some processing. And for something like this one, if not defined, this one, okay, it will determine whether the following code need to be used or not. You know what I'm saying? So this one include you automatically throw in. And then if there is if or and if, those kind of things, you may pull into your program, may not. But at the end, it will generate a whole thing that is purely C format or C++ format, and then go to compilation. It's no longer like punch something in the code. That's what the preprocessor will do. So your .h.cpp or whatever, it will be putting into a .c code or .cpp code. And then at that time, you do compilation and then go into a object file called .o or .obj, waiting for the linker to link. Okay, so what's the purpose for linker? You know what's the purpose for linker?
Not sure.
You have a program, right? You have main. So this one say a.c or cpp. The other one, there's another one called b.c, right? There's a f function over there, right? And this one is the f function. But when I compile to a .o file, I didn't know that where is this f function. And this one say I compile to a .o, b.o, this one a.o. A.o doesn't know where the b.o is. So when we link, actually this one create the link, the address to the port. So when it run the program, you know that, oh, I should need to go there and then finish and come back. So that's the purpose of linker. So you have a 10, 20 different .o file, but you need to link them together in order to become a real good .exe file. Is that okay? Otherwise, each object file has its own file and data and maybe the function, but they won't be able to call each other until you link it together. Is that okay? But this linker step in Java is totally different because it's actually like not really a full linker. It's a just-in-time compiler. It's not really a linker. So that one, the preprocessor sometimes is also called macro processor because like if define f1, we will replace all f by 1. Okay, so that actually is a preprocessor. And the C processor is intended to be used only with C, C++, and Objective-C source code. And whether there's an extension, maybe, but it's primarily for these 3 different languages used. Okay. Okay. Okay, then the C preprocessor and its role. So in the compiler like GCC, you have a C preprocessor and you have the CC1, that's the compiler, and compiler code to So the purpose of this preprocess is spend some kind of characters, discard white space and comments, and then process the directives. What is directive? Directive is these few things. There are 4 kinds, but here it lists down 3 kinds: file inclusion, macro expansion, conditional compilation. The 4th type is what? You saw it already. What is the 4th type? There are 4 types of directive. So directive is the instruction to the compiler. So the first type is file inclusion, second type is expansion, third type is conditional compilation. There is 4 types. What is the 4th type? You saw it already. You know that there is a 4th type, but you probably forget it.
I don't really remember.
P?
P?
Yeah. R? Remember that?
No.
You had a pragma.
Oh, that one.
So for library inclusion, like parallel processing or something, some special features. Okay? So remember there are 4 kinds: file inclusion, macro inclusion, conditional compilation, and special compilation. I would say that it's a special compilation package. 4 different directives. All of these are done before you send your file to compiler. Okay? All these are done before you send to your compiler. Okay, next one is the compilation flow. So compile your source code in C++ is a 4-step process. So it's a preprocessor, compilation, assembly, and linker. Okay, 4 different steps. So this semester, the coming semester, you're going to get ICS 51. It was placed strongly over here, here, here. Okay, this course you pretty much will be really good in C language and assembly for these 3 different levels. Before that, actually the traditional programming education is like C, C++, or Java, focus a lot on the front end, not the back end. Is that okay?
Yeah.
So, but this one starting from next semester, you are moving to here, more and more in here. So for example, if you have C++ source code and name program 1.cpp, and you execute the following compilation command. Okay, usually I just give you what? This gcc-o listens, and then this -o, I'm sorry. This one is one way to write it, and usually I didn't write it this way. Usually I put my cpp in front of here, and that's fine. This is the same. This one is the target. The executable code is following the -o, so this is one option. So you move this whole thing to the back, that's fine. Put in here is also fine. As long as you -o followed by the executable code, that will be fine. Okay. Assume that is not a problem. So right here, you actually try to compile this program called program 1.cpp, right? And here you have the standard using the C++ 11. So it's like C++ 2011 version, right? And what is this -wo? Is that for OS3 version? What's this? Eric, do you know what's this -wo?
No.
So this -wo means turn on all of the warning.
Oh.
So if you turn on all the warning, you will surely bug free, but a lot of things original can pass won't be able to pass. But some teacher would require you to turn on all the warning. When they say that turn on all the warning, you need to put this here. And then this whole thing, you should put in your dev C++, there is a parameter listing area, right? You need to put this whole thing there. Is that okay?
Mm-hmm.
That's called list. And then the compilation process look like this. The C++ preprocessor copy the contents of include file. So actually copy the whole thing from the include file, like .h files, into the source code file and generate macro code and replace symbolic constant. Symbolic constant is like define f equals 1, those kind of things. And then using the defined letter value. The expanded source code file produced by the C++ preprocessor is compiled into assembly. So it actually, when you have the C++ code, it compiled to a .s on the platform. And usually you don't see that, okay? If you don't dump it, you can dump the assembly code, but you can say not to dump it, just dump the executable code. And then the assembly code generated by the compiler is assembled to object code of the platform. And then the object code file generated by assembly is linked together with the assembly object code for the library function used to produce executable code. Okay, what is assembly code? What is object code? And what is executable code? Do you have idea? So your .cpp say I have integer I equals 1, say, right? And assembly code is something like move some memory location I with number 1, something like that. It will be written down with something like this. And object code is actually more like close to binary code already. And executable is the code really binary and run by the computer. Okay, so there are 3 different levels of the code. And object code is not linked. Executable code is linked. Okay, and then assembly code is following the assembly of your computer system. So next semester, the assembly and the object code actually quite important for you. Okay, so here I won't spend more time, but that's the process we have. Character set, source code character set processing in C and related language is rather complicated. The C standard discusses 2 character sets, but they are really at least 4. Okay, so character set used for the language, it's pretty complicated, and the standard says these are 2 character sets, but in fact there are 4. The files input CPP might be in any character set. So just assume that it's ASCII or it's Unicode, UTF-8, okay? Those are acceptable code. CPP first action before you even look at the line boundary, you will convert a line into the character set using the internal processing, okay? The set is the C standard code, source code character set, and it must be isomorphic with the ISO list. Okay, this ISO is called International Standard Organization. And then ISO number of this 10646 is one standard for the standard, and it's CPP will use the UTF-8 encoding. So can you understand this part, what it's trying to say?
Yeah, kind of.
So what is character set? And what is UTF-8?
Just different types of, like, machine code?
No, it's not machine code. It's actually test code. Okay. So why there's an ASCII code version and there's a UTF-8 code? ASCII code, I believe you know, it's just the American symbols, right? Letters and mapping them from 0 to 255, right? So that is fine. But if some guy writing the program from China, and there is English, but there is also mixed with some special symbol Chinese characters. Those kind of programs, CPP, need to be written in UTF-8. So what's that? What is UTF-8? You still remember UTF-8?
Like 8-bit or something?
Yeah, it's 8-bit based Unicode. Okay, it's slightly different from ASCII code, but it actually is. So this one is UTF format, okay? But this one doesn't tell the story. Let me try to find something that tells the story better. Okay, so UTF code, if some letter is actually the English letters, it will be just the same as ASCII code. So for some part, it's actually the same, right? But for some like this RE word or the Japanese word R, it actually put into such a format. So ASCII code is put into 8-bit format, and then some of the different data from different foreign language, it will be actually in different format. And that can be longer, so it's not purely 8-bit format, but it's some sort of extended 8-bit. So it can be like, so the ASCII region is only used from 0 to 127, so 7-bit for ASCII code. And after that, if there's a 1 on the first bit, and then it's all extension, you can, so it saves the last bit to see whether it need to continue to extend or not. The highest, the most significant bit is used. If it is 0, that means that, okay, my format stopped right there. If it is 1, okay, that's extend, continue to extend. Is that okay?
Yeah.
That's the UTF-8. And who is using UTF-8?
C.
No, UTF-8 is not used in C. UTF-8 usually used in the file transfer on internet. Remember that you do work on the ICS32 when we download a JSON file, and there's a function called bytes, and you need to convert the bytes from the UTF-8 format down to your computer. Remember that one? So most of the JSON file or the HTML file on the internet, it actually is saved mostly in UTF-8. And UTF-16 is used for Java, but it's because it's longer, so people try to save area and use UTF-8 more in transmission of the call or text call for the internet purpose. Is that okay so far?
Yeah.
So why here is said that, okay, the macro need to deal with different character set. That's because some people may be writing the CPP program in Chinese or something. So you can actually specify your input character set -F. It's called -F input, file input character set, with some option. And all pre-processing work is carried out at the source code character set. If you request the output -E, it will be in UTF-8. So if you have somebody say a comment like in Chinese, some good call or something, and it will be written in UTF-8 and save the original foreign language. Otherwise, it will be scrambled into the English binary format, and it is not good. So here, by appropriate compilation option, we can stop the process at any stage. So stop processing after preprocessor, you can use -E to end the processing. The expanded source code file will be printed on standard output. You can redirect the output file as you wish, so you can actually dump it or something. Note that the expanded source code file is often incredibly large because it's expanded. So you can actually do the pre-processing. After that, you can just get the pre-processing code and get it out. So -E, you will get the expanded code. -S, you will get the assembly. Is that okay? And this one, it will show on your screen. And then you just need to redirect it to some sort of code. Say you do this to prog1.e, okay? And this one, if you want to dump assembly, this one you say to prog1.s, okay? And C, you will go to .o. Is that okay? So these are, because we have different stage on compilation. So right here after pre-processing, you use you use -E, and you will be getting the expansion code. If you -S, you will actually get assembly code. If you say -C, you will get that O code. If you -O, you will get ESE code. Is that okay? So let's try this now. Since we talk about this pre-processing, let's try this. Let's try this in our window. This one is not what I want. Okay, anyway, let me try to find a directory. So let's go to this one. Say let's pick something easy. Don't get ourselves in trouble. So let's try something in chapter 3 and say this input file. Let me see. This one probably too hard. I don't want to get involved with some. Let's try this casting. Okay, this casting must be easy. So let me do Window R, put another window, and then I say CD space. Okay, and copy this in to my window. Okay, I'm here. Now, dir, I have some C code and executable code, right? So now I do GCC and then -O, A or O warning, and then what? And then -STD equals C11, right? Something like that. And now I use a -E and then casting.C. Okay, and I cast this one to casting.E. Okay, then I will get the .E file. Let's look at the .E file. What is the .E file? Let me try to open it with the notepad. You see that? The code being expanded to such a format. Okay, so it actually got expansion, but it's still have the C-like language. Is like this integer and some attribute function code still be there. But you see, because you include all the file from library, so every library's function code folder all been included, and it got modified. So some file, you see that the main program is just like this, but actually the include file is so huge. But in order to see how the expansion being done, you need to do the way that I do. Like this, turn on all warning is fine. The standard compiler version is fine. You do -E, and then here I have a greater than symbol, and then casting.E. If I don't do that, okay, if I don't do that, what will happen? If I don't do that, say I have GCC, then -E casting.C. What will happen?
.C.
And I do not have that this greater than to this casting.E. What will happen?
It does it backwards?
No. What's wrong with it? It will go to screen. So this one greater than, we call it redirection. Redirection. So I have something running, my output will be redirected to casting.E. Is that okay? Okay. So I have something to do, and then I redirect something to the. In Unix, you have the same function. Okay, whatever you print out in the screen will be there. Okay. So let's do this. Okay. For example, I have this casting. I run the casting. I get such a result, right? Is that okay? So if I do casting and then redirect the output to out.txt. Okay, what happened is, like, if I open this one, it will be the output for the file. Is that okay? This try to help you to save if you run some program and you want to save the result, you will go to there. Okay, and then the next one we have the GCC casting -s casting .c and then casting.s. What would this be? I just talked about this a moment ago. What would this be?
.s?
Yeah, that is what it would be, the .s format. Oh, I'm sorry. Let me see. Let me see here. Let me see. Did I make something wrong? Yeah, should be. Let me try again. GCC casting .c -s casting .asm. Let me try to dump a different one. Okay, it seems like it will accept this format. But what would this be? What is the .asm be? You open with. Hey, I already have the Visual C++. Let me open by that. Actually, I have that. Okay, and then I open with Notepad++ as well. Oh, usually it's an empty file. Is that reading? No. Oh, I'm sorry. It should be. I'm sorry. I make a mistake. It should be before the. It should be before what? I make a mistake. It should be before the C program. So it's GCC -s casting .c dumping to. Let me see how I work on the E part. Wait, where's the E part? E part is up there. So E part is -e to casting. Okay.
Call from 510.
So here, let me do casting .c -e to casting .s. Okay, so I got the .s file. It's assembly source, and then I open with Notepad++. See that? So this one is the assembly code now. This one is the assembly version of the code. Let's go down to here. Wait, this one is still. Did I make mistake? Oh, I put .e. I'm sorry. GCC casting .c -s to casting .s. Wait, they're not open for writing, so I'm sorry. It probably already open or something. Let me close this one. How come she keep doing that? GCC casting. So the .s file may have special meaning. To casting .s say. Okay, .s is fine. It had nothing. Okay, whatever. There are some other way to dump assembly. I'll show you later, but this one doesn't seem to work for the one it described. Okay, maybe only work for G++, but I'll show you the dumping way for assembly later. Okay. Now the next one is like if you do .c, we know that you would go to a .o file, right? And the .o you will go to executable file. So these are the GCC steps for partial file building. Okay, these are the. Whenever you need something in between and you try to check it, you can use the GCC partial compilation feature to get that. So let's move to the next page. So right here we have this one, okay, and then we try different test mode. So the first one, we do test G this and then dump this to assembly. So to dump assembly, you need this one. So probably that S1 is no good, okay? That S1 is no good. So we have this one, bse2.bat. We have this one, assembly.bat, assembly2.bat, a few others. So let's look at that, this assembly one. I have the example, okay? So let's look at that. That will give us more details. So this one is chapter 7. So let me go up. Chapter 7, and then CD. This one should be macros. I'm sorry, it could be in. Let me try this include. Okay. No, this one's bio. Okay, let me try to bring up Windows. So let's go to chapter 7. Here we have the include, right? Let's look at the bio function. The bio function is -I, whatever. And then let's look at the other one, macro. We have bio function. This is macros. How about this one? This one is in test mode. Probably not in this directory either. Oh, could be the one in mode. I'm sorry, because it has been some time. Let's look at mode. Yeah, it's in here. Okay, it's in here. So let me do this. Window R. Okay, go here. Then I CD here and use this one. Copy, paste here. Okay, here quite many mode. Let's look at one by one, okay? Let's look at the mode one by one. First one, let's look at the program called test mode. .c. It's quite simple, right? It's actually a very simple program. Purely very simple program. And then let's try the first one, this normal one. Normal one is BOESE2. I'm sorry. Let me try the assembly one first. Okay. Let me try the assembly one first. So the assembly one is BOASM. Let's try this one. So this one, you compile it, -G-C, you will get the object code, and then using object code to dump S. So this is the right way to dump assembly code, but the ones described here may be too easy, okay? Maybe too easy. Maybe too easy. Anyway, so now if you want to dump assembly code, it may be too easy by using that. But maybe it's too easy.Maybe it's because like over the year it changed already. So here it actually tells you I'm going to dump the -O code into an Intel format. Okay, so that's what this is. So let's do this. In here, let's try build ASM. I'm sorry, is that build ASM? Oh, I'm in the wrong directory. Sorry. Now this one, let me close those are not matching our purpose. This one, okay, and then here, build ASM. Okay, done, right? And so it actually dumped to a test mode.asm. This file, and as you can see right here, right now it's in assembly format. Assembly format. Each of that thing here is a instruction for Intel processor. Push, move. Okay, these are the instructions. These are, and then this is actually like memory indirect addressing format to access some memory, and this EX is a register, okay, and then call some if function or something, whatever. So this is called assembly, and this is what you will learn in ICS 51. And you sometimes, if you don't know how to write assembly, just use a simple C code and dump it, and they will write better code than you. So the main function in C language actually equivalent to this in assembly. Okay. So the main function, what you see there, it will be this. So there is a printf or something. There's a function call. You need to go to the system. There's a printf function, and you will call and process in this. Is that okay?
Yeah.
So that's the assembly code. That's the first stage. When we actually go into the execution flow right here, after compilation, you start to get S. Okay, that's the assembly code. Now let's look at another one. So the assembly code has been dumped, okay? And then I'm trying to do what? This one, I'm trying to do GCC O2-S. This, you will have another way to dump to S code. So this one actually there is a -O2, okay? But I didn't know, probably that one need a -O2 in previous version. So let's look at this assembly 2. This one. Okay, it's a big O2, okay? Probably that's what been updated. So here I build ASM2, okay? And then it will have the result. It will have the result stored in -S file. So there is a -S file here. Let's see. Okay, that is a better assembly code, better than the previous one. It's more clean, right? It no longer has that command. So this is the one people really need for assembly. So now let's go back to the previous example, the casting one. So here, let me open another window. Maybe that -O is what it needs to be. So -O2. So let's go to here, my Eric Chow into my C language programming essential, and then go to my chapter 2 casting. Okay, right here. I also window R. Okay, and then I cd to this directory. Okay, get used to what I'm doing right now, because on your units it will be similar process. Whenever your school give you, it will be in similar process. And PIR right here, right? So what I'm going to do is GCC and -S. -O2, right? It's a big O2, right? Big O2, then -S casting.c, and then redirect to casting.s. Wait, how come it still don't work? Let me try one more time. Oh, don't redirect. Okay, it will automatically give it to you. So, I mean, these are some niche. Okay, sometimes the compiler change, and I'm still using the old material. So that could be the error. Oh, okay, now it's done. Let's see if this one works now. Is this one the one we got it, right? We got it, right? So whatever I'm written here is wrong now. So what it actually need to have is this one. Before we go this here, I need to have it big O2 here, right? And this one I need to say redirect to pro one.e, okay? And this one should be okay. I might make such a note, otherwise next time I will forget. This one actually you will go to the screen, but I want you to dump to some E file, right? So apparently this one work, okay? This one work, but you just need to pick O2, okay, like oxygen, and then -S. It will give you the assembly. And if you don't know, say if you actually, this is the most important part I want to show you today. Actually, if you try to write some program, right, assembly program, but you don't know how to write it, and you try to dump this, it will help you to understand how can I write a assembly code. Is that okay? Later, you will use this skill pretty often, I would say. You probably will use that very often because you are not born to write assembly code. So that one is fine. The next one is similar. The usual things that you compare to -O that we compare many times, so I will omit it. And the one for execution code, same thing, right? These are okay. We've done this very time. And the object dump to assembly code part, it will be an object assembly code with some description. This one, you also need to know that it's here. If next time somebody need you to do that, it's always in this chapter 7. And that's why I try to create this whole series of things. So when you actually in school, you actually know if you run out of the option, and you still can come to here to find those code and whatever in here. Okay, it will help you. Okay, so I try to organize different codes, then you can download source code in different chapters. Okay, so that's what I'm doing right here. So this page is assembly. Oh, we are only at the page 11. A lot of things we just in page 11. Let's try to speed up. You know, this thing is actually quite complicated. So the next one is macro. Macro is easy. Macro, C processor will modify your C code to set typing. So macro is used to define constant, define macro, include file, other parameter, conditional, compilation. So there are 4 different directives. It's called directive to teach your compiler how to do. So the things that you can have a define, you can put the replacement token list. So here can be a modifier, here can be a whole list. So actually this one is used to say for example, here you can say call F, right? So right here it can be like F of X 3, 4, 5, 2x 2, 7, and then B something. So for example, you don't like to call this many times and it's too long, you don't want to type it, you can actually set up a macro, and in your program, whatever call F part will be replaced by this function code. Is that okay? Or you say this debug is 1, it will replace by debug. But sometimes you don't put anything, that's just to define debug. And then if you have the if not defined, you will know that, oh, okay, this is already defined. I won't do that. Okay, so this macro has something you can replace the code. Second, you can replace by a constant, that's fine. Third, you can do function like. You can use the replace token to replace that. Say, I'm running this, right? But it's just like I'm using a function. So when I do x, this x is a symbol. It's like radian to degree. So in my C code, if I write radian to degree and 35, it will be replaced by this. Is that okay?
Yeah.
So macro is used to replace your code. Is that okay? So I think this sometimes there is a test. This is a good thing. So it's defined symbolic constant like this, or you can do this, or you can do this for a circle. Okay. So, but here, one thing you need to understand is that it's a text replacement. So your radius must be meaningful in your function, must be meaningful in your program. Okay? If your radius is not defined, then this one won't work. Okay? It's just a text replacement. It's not really a function code. Is that okay? So you can define verbose, and then if verbose is defined, you can leave it blank. So if it's defined with verbose, then I'll print this. And if I say if I comment this out, no verbose, then I'll just say hi. Is that okay?
Mhm.
So verbose don't need to have a one. It doesn't need to have replacement. Sometimes it has, but sometimes it doesn't. If it doesn't, then it can be used for it is check if defined or if undefined, not defined. Okay, two different if type macro you can use. Okay. I believe that this part your teacher didn't teach you in school, right? Because it actually very tedious and they will assume that you know it. So this one like this square, right? So whatever in your program is a square x, it will be replaced by this text. But you better know that the x has definition, otherwise it won't work. Okay, and this one, which one's better? This one's better because you always will capture it. Sometimes this one, because in front of it, it maybe have a one, and you don't know it just miss or something. You know what I'm saying?
Mhm.
Or say here actually you want this, right? But it actually in front of it there is something like cap or something of higher priority, and actually this x will be operate with the previous one. So this version is better, you know, because the x won't be processed by whatever in front of it. If there is an operator stronger than this multiply operator, it won't be something like that. So here I say integer x, right, and x equals this, right?
Mhm.
And then here it replace the x here. What will be the output for each version? So I have an x, right, and I have a square x, and this one plus. Will you be something like this? And because if I use this, it replaced by this, it's not a purpose I want to have for this. So if I had a parenthesis version, it's better because it will put parenthesis in front of it. Otherwise, the 3 and 1 will multiply first. You know what I'm saying? Is that okay?
Mhm.
And this one, macro 1, I have this, so I have A plus B, same thing. You better write the macro with parentheses. Okay, then A and B will be replaced that. Okay? So this part, I think just be careful for it. And here we have this example. So here is square equals this. So the x, square x will be replaced by this. So it will be this. So right here, it will be A of I equals A of I times A of I. It will gather that, and then you print out the data. Okay. So remember what will be replaced. This one I'll omit. It's not too hard. Okay. Getting fancy with macro. So macro actually, since you have this, you can put a structure in there. So you have a type, so integer. And then it will be Q node. It will give you replaced by this. So this one is somewhat like what? It's somewhat like a generic in C in Java. It's somewhat like you put a string for array list, right? Somewhat like that. So basically, this one define this. Then when I use it, say later if I use it, it will you just put a Q node integer. You just put a Q node integer. What will happen? It will be replaced by this, and here become integer. That's the good part for this macro. So it's somewhat like a generic programming. You can set the Q node structure with integer, with double, with flow, with whatever you want.
Mhm.
So know what I'm saying?
Mhm.
And then that Q node will have insert whatever. You will just replace those different type or variable into there. Okay. So that's why this macro is very important. Sometimes very important. What is this backslash? What it is backslash? It put the whole definition for macro as a whole. But treat it as one line. You know what I'm saying?
Mm-hmm.
Macro must be written in one line. It's not like normal C language. It need to be in one line. But in order to make it put it in multiple line, I use a backslash to connect every line together into a line. So I can use the Q node for more complicated structure. Is that okay?
Uh-huh.
So here I have different function for that. So that's why I told you this chapter is not teaching you C. Instead, it's teaching you the preprocessor. And it had nothing to do with C language. It actually teaching you how to use the preprocessor. Say right here, when I call a Q node, right, and WTH type, so it actually is a WTH type will be here, right? It will give you a structure of the WTH T type. No matter what it is, or this makes sense or not, that's fine. So it will be something like this. The Q node will be used. So there are 2 pointers being put in there. Okay, so what this is like, I think this one is somewhat like a linked list or something. So here I have a node. There is an integer called stay, right? I have a structure, and in that structure I have a next, and I have a previous. Look like it's used to pointing to the previous one. Okay, so actually you got expand to this. Okay, so this is a list. Some sort of list. I don't know what this is used for, but it should be something like that. Okay, and then memory layout, it will be something like that. 3 words in memory. When you compile, it will be 1 integer, 2 ages pointers. Okay, but the previous is a second order pointer. It's a pointer to pointer. Is that okay?
Yeah.
Is that okay? And these pointers are the WTH type. So it's just like I have a structure, right? Integer, and this one pointing to here maybe, and this one pointing back to here. Whatever, is just something like that. Okay. And pointer to pointer should be here. I point to a pointer, and then that pointer point to here. Okay. So something like that. Something like that. This structure may not be used like the one I throw, but will be similar to that. And in memory, it just store 1 integer, 1 pointer, 2 pointer. Okay, pointer to pointer is still a pointer, still stores pointer, because it's point to a pointer variable, and pointer variable ages is a pointer. So Q node initialize function, you put a node, and you actually do something. This is a do while, right? This is a do while, and 0 is false, so you will never do anything. So here it remain that you modify the code if you need to modify the code. So each time the node is a pointer, so next will be will receive the current node. Okay, and then the previous field would be the ages of the next ages. Okay, so what this is it's trying to create this one right here, right? And then I have a node, say this one's node. Node's next is node. So node's next pointing to itself. Okay. Node the ages put here. So it's ages. So it's ages put in here. I don't know what it is, but it just put the ages of this node here. Maybe it want to be modified, so someday later this one will be modified. But let's just stop here and take a look on the next one. Okay, and then it will be created with this. And this actually has 2, 3 different numbers. This actually is after linking, it will be like this. It really link to some memory edges. It will be something like this. That's what put into your memory. Is that okay so far?
Yeah.
It's somewhat more machine level, okay? So preprocessor macro, using macro as function, exercise with caution. So be careful when you write it as a function. And this one has 4, right? One problem is that you like to have the parentheses more. So multiply this, it will be like this. It's no good. Okay, you want to have the parentheses. Okay, something like that. And side effect is like you may have this one, right? But you get the data, but it's not after the processing. So something you need to be careful. So here, that's macro. The next thing is called inline function. Inline function is different from macro. So we finish macro. Macro is text replacement. It's just one thing, text replacement. And inline function is a pre-compiled code inserted to your function. Okay. And you probably heard your mom say that inline function, she never understand it. So inline function is another part. Usually the macro inline function put into .h. So that's why here this .c file is over here, right? And it got used to replace something, right? And inline function similarly, it used to replace the f function in the code. Is that okay?
Yeah.
It's similar, but it's a little bit different. Both of them put into the .h file. These are functions provided by C++. Inline keyword used to declare the function as inline. Okay, it declares inline. It can be defined inside or outside the class. Okay, inline functions are parsed by the compiler. Okay, inline function can access the data member of the class. Remember here, inline function can access the. So inline function is still a function. Macro just text replacement, so you won't be able to access the member of the class. That's a major difference. Compiler replaces the function code with the function calls. Inline function follows strict parameters checking. So inline function just a normal function. Macro just doing text replacement. Inline function may or may not be expanded by compiler. Okay, because inline function is a function code. It just pre-compile and you insert into your function. Can be used to debug function. So sometimes you just think the inline function is a function and put into the .h file. That's it. Okay. Other than that, when you meet the inline function, be careful if something go wrong. Okay. Otherwise, you just think about inline function is a function, but you put into the .h file. Now, this one is the one you asked, the pragma for expansion for compiler. So, for example, I have a parallel C, right? And I want to do parallel for loop. So for this one, I want to do this hello world in parallel. So you will fork out to 3 processor, print out the same hello world. Okay, and portability for pragma, C++ Builder has that, GCC has that, Intel C++, Microsoft Visual C++ has that. Not every compiler has that. So this directive is used to insert compiler-dependent comment to files. So actually is allowing the OMP. OMP is open. This one is like message passing, open source message passing. So it's for parallel processing use. Okay. And that, well, right here, this one, which course you may need to use this? The 53 may have the chance to use it, but maybe not. Okay. But here I just give you some idea what it is. When you meet it, then see what it will be. Include is okay. You actually do this several times. One thing to learn is when you do GCC, you put another code from somewhere as your own library. You can do -L for library. So normally I'm running on my own directory. Say this directory 1, right? And I may have a directory 2. I want the code to be here, but I also use this code 1. So with that, I can use -L and find those code from there. Is that okay?
Mm-hmm.
If not, you can also put the file name as absolute path. Then you will be able to find it, okay? What is absolute path? And what is the relative path? What is the absolute path for directory and what is relative path for directory? Say,
I don't know.
you don't know?
No.
You have a file folder, right?
Yeah.
Let me pick one. Oh, this one. This is absolute path. It starts from your C root, Eric Jones.
Oh.
And if I don't do that, I just say, if I say, this is absolute path. Absolute path means the whole path. And if I say dot lecture, this that means current directory. This is relative. Or sometimes you don't do this, you just put lecture. It's current directory. Okay. If dot slash, it means the parent directory. So it means the parent directory. So C programming essential lecture. So for example, if I have like C 2018, right? But in my program, I'm in here, right? So I'm in my lectures, right? But I want to go to somewhere in the C 2018, right? So what I'll do is, okay, I don't have my absolute path, so I do dot and then / C 2018.
Mm-hmm.
And then some file name, something like that. Okay?
Uh-huh.
That's the so-called relative path. So your directory, file directory can be absolute path, can be relative path.
Mm-hmm.
We finished the inline. We are in relative path. Okay. The next one is the header file. Header file, we finish this. I know you know this, right? So you just put a header file like this. If not defined, you will define it. Otherwise, you won't define. Okay, that's fine. Source code and header file, you have a .h, and then usually header file export the interfaces to definition. So a .h and .cpp or .c is a module. And whatever interface put on here, whatever implementation put on here. Okay, so it like inline code, class definition, constants put in C++. Sometimes inline code you can also move to here. So this one usually prototype, data type, macro, inline function, common declaration. Okay, that's a breakdown between your two different file. So C processor or CPP is used to insert common definition to source file. Okay, we know that. But the function of the .h and .c or CPP are different. So the standard library, the most famous one for C language, are these. These you must know all of these. These are commonly used. You know, we teach C type so far. We teach flow, limit so far, mass. We know that. standard pool or standard int. Okay, string, time, std, these two, and system/file, right? System/file is very important. That's for reading file input or output. Okay, next one. See standard header file you may want to use. Standard IO for these different functions. Standard library for memory allocation. This one's ASCII to integer. This one's ASCII to integer. ASCII to integer is very often used. In Python, it's called ORD, order of the integer. In Java, it's what? Java is what? Java no need, because Java itself is a character. Itself is an unsigned integer, right? So or you just put a int, you can execute it. So Java has no such function. But it's AOIT is very important. String.h here you give you a string. C type give you is a number, is an alphanumerical number, is a print, is support to lower to upper. Okay, this one for type conversion. MS function we know, signal function we know, stdio. This one signal is what? For the something like exception type of things, right? Erase those kind of raise function. But it's old-fashioned because this one is C standard. And std integer for this integer type time. And these, when you use these in C double plus, you need to put a C in front of it, okay? If you use in C double plus, you need to put C in front of it. So next one, simple C program, we do try to compile and execute it. Okay, in Unix, it always teach you, maybe tells you to do this, but in your profile file, you can set the current directory in the past, then you don't need that /. But if you don't do that, you need to do the relative address, okay? And this one, exit 0 will return a 0. To exit the program, it will return the error code. And the error code 0 means no error. Okay? Now let's check how many pages we have left. We have about 10 pages. Okay, keep going.
Okay.
And then we have std. So these two got inserted in this program, right? We talked about this already. Next one, include package demo program. Oh, that's in the include. Let's look at the include file. Chapter 7 include. That's in include. Let's look at include the C. Let's do this. Oh, here has the include. So include, I have an A program, A.h over there, right? And in my include, I have that. And then in my build function, I have this -i/i, whatever it is, right? And whatever is O function. That's the way you include things from using the compiler. Okay, that's the, so here user defined library. I can I can actually put my A function into that I library. So I itself is a library. So I have a -i and then this and this. You will call from the library. Okay. And then my I directory is this. I should use live, but maybe better, but this I already use it. So here it has the I itself, the A function is a macro function, and this one has a F function, and this being used by this. So if I don't use this -i, I put the A.h, A.c, test.c in same directory. That would be easier, right? But here I just do it on purpose to put that two into a library called I, and then I use a relative address to declare the library is from here, and then the .o file is from here. Okay. Otherwise, I just do a.o, right? And then I don't need to specify the library location here. I will be able to compile. That's what it is. Not too difficult. So preprocessor derivative, you have include, define, conditional derivative, and then the pragma and then operator in preprocessor. That's fine. So preprocessor, the C++ preprocessor permit you to define simple macro that are evaluate expansion. So here are the macro. Okay, I don't want to repeat. Conditional compilation, we see that you have if defined and if undefined, right? And that actually give you to make sure it won't actually reinsert the same module into a file, and that will cause compiler to stop, right? And here is another compilation, conditional compilation. That means if you define the underlying window, it will be window platform. Otherwise, it will be standard Unix platform. So it's used to do the compilation on different platform. Is that okay? Hello? Hello? Hi, Eric. Is that okay? So debug is like debugging. I don't repeat that. I teach you many times for that. So this is A-C. So here, this one I show you already, because sometimes I just want my program to be used by other people. So I set it debug mode to be not define the debug mode. But if I turn on, I can use this as a program to test the whole thing. But if I turn off, I just have this for other people to use. Okay, that's the debug mode setting. So I teach you the macro mode, the .h file, and I also teach you the debug mode when people use it. Okay, this one similar. Okay, and what's this? B. Okay, here is defined. Okay, so here is, you can also do this, include this and undefined debug. Okay, you can do define or undefined, and then you will check the value whether debug is defined or undefined. Okay, so then the multiple file program. So a program is broken up into main A-C, B-C. You can define a function in one file and try to access them from a second file. Declare them as external symbol in the second file, and do this with external keyword. Okay, that I teach you before. External means what? What does external mean? When I last time teach you. Hi, Eric. Hi, Eric.
Yes.
What does external means when I last time teach you?
It's like
public. And also shared, right?
Yeah.
One of these. Okay, be careful. I know you are tired, but just want to make sure you're still listening. We are about to done, okay? And the second one is you have separate compilation. Where the previous one you compile together, and second one you have a separate compilation, and use a header file to define the macros. Okay, that's the second way to compile it. So which one's better? Well, it depends. You have to check the following 4 different features: reusability, debuggability, convenience, and project scale. When project scale bigger, option 2 is better. If the project scale is smaller, you put it into one compilation is easier. Okay, that's it for today. Thank you. Bye now.